Okay, so last part of the level 5, which is chemical energetics, we are looking at Hess's law. So this is a new law that you need to know, or actually more need to know how to use in your AS chemistry. So this law is based on the fact that energy is conserved on Earth. So the conserving energy cannot be created or destroyed. So this is the concept where Hess's law is based off, and it's important to keep in mind, because if you remember this, then the idea of Hess's law might be easier for you to grasp. Okay, so Hess's law states that the total enthalpy change in a chemical reaction is independent of the route by which the chemical reaction takes place, as long as the initial and final conditions are the same. So what that basically means in normal English is that, let's say I want to make ammonia, NH3. And there are, let's say, two ways to do it. So the one way, I have to take 2 steps in order to get ammonia, and the other way, I need to take 3 steps in order to get to ammonia. Then the enthalpy change for either one of these reactions will be the same, even though the one has 2 steps and the other one has 3 steps. But what is important is the fact that the initial and the final conditions need to be the same. If you start the experiment in 25 degrees Celsius, you need to end the experiment in 25 degrees Celsius. Otherwise, your math doesn't add up. Okay, so it doesn't depend on the route. The total enthalpy change doesn't depend on the route taken. It's like gravity. Gravity doesn't depend on the route that you take, but friction does. The longer route you take, the more the friction is. So it doesn't depend on the route. Then here is just an example to show you. So let's say I have A and I want to get to C, whatever C is. Now there are three ways that I can do it. I can go from A to B and then from B to C to get C. Or I can go straight from A to C. Or I can go from A to D and then from D to C. So the enthalpy change for this from A to C via B is the same as the enthalpy change for A to C straight, and that is the same as the enthalpy change to get from A to C via D. So you will see I wrote it there in color coordination. So the total enthalpy change for this route at the top is the same as the enthalpy change for the straight route, and that is the same for the enthalpy change for the bottom route to take. So please keep this in mind. So that is important. Then just a recap of enthalpy changes. Remember, we had our enthalpy change of reaction, formation, and combustion. So these really come in handy and are very important for the Hess's law. So enthalpy change of reaction is the enthalpy change of a specific reaction. That's what it is. Enthalpy change of formation is the enthalpy change when 1 mole of a compound is formed from its elements. So this example is a reaction for the enthalpy change of formation, because water is formed from hydrogen and oxygen. Okay, and then enthalpy change of combustion is the enthalpy change when 1 mole of a substance is burned in excess oxygen. So you will see here 1 mole of the C2H6 is burned in an excess of oxygen. So those are the enthalpy changes that is important for you. And yes, so well, just another note about Hess's law. So you don't need to be able to state Hess's law in words or know the definition for the law or whatever, but you need to know how to use it. They really focus on how to use the law. So we will look at that in class, but this is the theory that you guys need to know.